Okay, so we're moving on to 5.2. Starts on page 191. We're going right to page 192 because we've pretty well discussed how we're going to go about graphing this. We're going to use a chart to actually figure out what our coordinates are for our figure. So we're going to go through some of that right now. But a little bit differently, because we're going to look and we're going to find out what the graph is, because we're on example 2. We're going to find out what the graph is of, find the graph and what we're going to find the graph of is f sub x equals y equals x plus 1 where x is less than or equal to 2. Now, I showed you some of that in the last drawing, but let's just make sure that we're talking about the same thing here. Then after we've discovered this, we're going to go and we're going to discover a different f sub x, which is still going to be equal to, same f sub x is equal to, and it's going to be equal to negative 3/2 x plus 6. And that's going to be when x is greater than 2. Wow, doesn't that look like it's going to turn out to be a mess? It's really not that difficult. First off, we want to graph x plus 1. At least mentally we want to take a look at that. Now, x plus 1 strictly looks at x. And then adds 1 to it. So, and I don't want to make this too configuring, but if I say x plus 1, I already know where my y-intercept is. So the y-intercept, we're looking at y equals mx plus b. We're looking at that for x, and I want to use the right color here. I know it has to go to that point. X plus 1 has to go to that point. Right? Now, having said that, if x of x equals x plus 1, then the line for that is a positive line. It's going to go in this direction. And it's just x. Right? So it's going to be here. It's going to be here. It's going to be here. It's going to be here, it's going to be here, it's going to be here, and it's going to be here, and it's going to be here. But remember, it has to be less than or equal to 2. So everything that's past this point right here, which is 2, right? It's supposed to be an arrow. Showing me that's 2. I'm not going to use. I'm not going to use that. Gone. And I know it's a whole spot. It's not a hole, pardon me. It's a filled-in spot because it's less than or equal to. So now my line for that constraint is going to look just like this. Now look at that and make sure that you understand exactly why that looks like that. That's the check mark there, right? We got that, right? Now on the other side of that, we have to draw the other line. The other line tells me I'm going to go negative 3 over 2x. And I have to cross positive 6. Positive 6. So immediately I'm thinking, oh, guess what? Right? And we see what's going on here. I'm going to start out by looking at this 1, 2, 3, 4, 5, 6. And I'm going to do it in that red that I've used for my X and my Y. Now I know I'm going to drop down 3, Y over X, right? Drop down 3 and go over 2. So look at this. It matches that spot. Drop down 2, but X now has to be greater than 2. Now, herein lies the problem. But I know this line has to look like this. Alright, I'm going to drop down 3 and go over 2. Right? So it goes to here, right? And it goes to here, right? I want to use a different color. I want to use a different color. I want to use the color of what I wrote that in. Right? So it's going to look like this. Can you all see that? I'm hoping you can. So X now is greater than 2. Now, herein lies the problem with this particular model. And it's not a big deal, but it's a deal. What happens here is this one should be a hole. At least that's what you may believe. It's not a hole because this is a constraint. Alright, not a hole. If it were here that I was looking at that, or I was looking at that here for f sub x, then I would worry about whether it's a hole or not. Okay, now that gets us through example 2. The only thing that changes there is that we're going to be looking at different pieces of it. And if you go through example 3 in your textbooks, that'll show you exactly how to get piecewise defined functions. Piecewise defined function in this case, if I said one is less than X, or whatever I'm going to use for that. Hang on, let's make a little bit more room. If I said X is greater, is greater than 1, right? X is greater than 1. No, X is less than 1. Sorry. I had it right the first time. Sorry about that. 1 is less than X. It means that X is greater than 1. And then I said X is also less than 4, then the section of the line I'd be looking at for a piecewise function would be, and I want to use a different color here to show why I do, I'd be looking at this section of the line, only that section of the line. That's what example 3 show you with a word problem. Now, I'm not giving you a lot of word problems because I want you to understand how this works so that you can move on to geometry. But our line at that point is going to virtually be that little section right there because of this constraint. Okay, that should set you up so that you'll be able to go through the 4 examples that are given there, including the example of example 4. Example 4 says apply a piecewise defined function. Remember, Pearson has even more examples of how to do this stuff. So, ask me, go to the Pearson website, get her done.